This lesson is for Advanced Algebra, Lesson 2-6 on inverse variation functions. Lately in Chapter 2 we've been talking about some direct variation equations like the linear one and the quadratic one. Today we're going to look at some inverse ones. The first one is a hyperbola. It's a little bit of a different word, so I want to make sure that students understand how to pronounce it correctly. When you pronounce it, you put the emphasis on the second syllable. And so when you pronounce it, you say hyperbola. So try practicing saying that out loud to yourself. Hyperbola. So the equation that this comes from is y equals k over x. And you'll see that the graph has two branches. Together those two branches are forming the graph of the hyperbola. When the k is greater than 0, or when k is positive, the branches will be in quadrants 1 and 3. When k is negative or less than 0, the branches will switch to quadrants 2 and 4. The domain and the range are also listed here. The way that the book lists the domain and the range is that x and y can't be 0. We'll talk about that in a little bit. Another way to state that same idea is that the domain and the range, when k is positive or negative, is all reals except 0. And so to me that indicates that students understand it a little better, other than just saying y and x can't be 0. If you want to say what the domain is, it's all reals, but it isn't 0. So let's talk about why it isn't 0, and why 0 is not a part of these equations. You can't divide by 0, so x is never going to be 0, and if x is never going to be 0, we're never going to get a 0 outcome for y either. So both x and y are never going to be a 0 value. So that's why the graph is basically avoiding hitting any of these axes. It's never going to hit the x-axis going this way. It's never going to hit it going that way. When we go up, it's never going to hit the y-axis going up, and it's never going to hit the y-axis going down, because those would all become 0. And 0 just can't work for these. So basically what students are going to need to know how to do is how to graph these by hand. There's one more piece of information which we'll go ahead and fill in later, so leave a little bit of room there for your notes. Let's go ahead and try graphing 12 over x by hand. So whenever you're asked to graph by hand, you should use a table. And so we're going to make some x's and some y's. Be smart about what you choose here, folks. You don't want to pick numbers like 5 for x, because 12 divided by 5 is not going to give us nice, easy numbers to work with. So be smart about your numbers. Let's pick numbers like 0. We wouldn't want to choose because you can't divide by 0. If we did 1, 12 divided by 1 is going to be a fairly large number. I'm probably not going to graph that, but I'm going to leave it in my table regardless, because I did go ahead and calculate that. Next I'm going to do 2. When x is 2, y is going to be 6. When x is 3, y is going to be 4. When x is 4, y is going to be 3. And let's do one more. 5 I'm not going to do, but let's try 6. 12 divided by 6 is going to be 2. So let's go ahead and graph what that looks like. Before we do that, let's do a quick prediction on where we expect the graph to go. This is a positive k value, so real quickly we know that the branches are going to be in quadrants 1 and 3. This table has only positive values in it, so I know that I'm going to simply be in quadrant 1 for now. When I'm done graphing this particular branch, make sure that you don't quit, because you need to do the other branch before you're done. So make sure you have 2 branches pictured. So my first one, I'm not going to graph 1, 12, let's graph 2, 6. And then 3, 4. 4, 3. And then 6, 2. And so right now I don't have that much of a graph showing up, but I can tell that I'm getting that branch that's going to be in quadrant 1. So now just sketch that very carefully and show that it does go down to the right, and it's going to continue to go up. Be careful here when you are sketching these. Make sure that when you're graphing it that you're not being sloppy and doing one of those for your branch, because it should not cross the x-axis. Another thing that tends to happen when kids are going too quickly is they draw their branch, and then at the very end it kind of goes up a little bit, almost like a parabola. So make sure that you're graphing accurately. I will be looking for that on your graphs. So we have our first branch. We need to get another branch in quadrant 3. So let's just add to our table here, and let's fill in some negative numbers. I already know I'm not going to use the 1, so let's go to -2, -3, negative 4, and negative 6. When you plug those in, it's 12 divided by each of those, so I know I'm going to get all negative results. And those should match with exactly what I had here. Negative 6, negative 4, negative 3, negative 2. So I'm going to go ahead and graph those, and that should be my other branch of my hyperbola. Negative 2, 1, 2, 3, 4, 5, 6. Just barely made it there. And negative 3, negative 4, negative 4, negative 3, and negative 6, negative 2. So when I graph that one, get a nice curve there, and now I've got my other branch. The only other thing that I would suggest here is that students extend their axes a little bit to include how large their graph actually ended up being. You want to make sure that your axes extend at least to the point where their graph goes, if not beyond. So that graph looked the way we expected. It's got branches in quadrants 1 and 3. The other graph we're going to look at today, the other inverse function, is the inverse square curve. This one doesn't have a funny name like our first one did. This one simply matches with the equation that it comes from. If you look at the equation for both of these graphs, the equation is k over x squared. That is an inverse graph or an inverse equation, and it is being squared. So the name here really matches with the equation that it came from. It's an inverse square curve. So we're doing k over x squared. When k is positive, the two branches will be in quadrants 1 and 2. When k is negative, the two branches will be in quadrants 3 and 4. There was a mistake in the book here. I want to quickly show students that. When you look at your book for the inverse square curve, they do have a mistake in the range. Make sure that your range is matching with the k value. It should be greater than 0. They have it correct for the range of the second graph here. And so let's also talk about these graphs and how they look. Notice that we still have two branches that we need to worry about. But now the second branch is not down here in quadrant 3 like it was for the hyperbola. It's been flipped up to quadrant 2. The reason for that is when we square negative numbers, that's going to turn it positive, so that flips up our branch into the other quadrant. I usually refer to this graph as kind of like a volcano. It's real easy to draw in the air with your fingers. Hyperbola, it's a little bit more difficult to draw in the air with your fingers, so typically I have kids do that for the inverse square curve. Let's go ahead and try one of those by hand. So I have you doing 16 over x squared by hand. Let's go ahead and make our table. Do a quick prediction on what we expect it to look like. It's a positive k, so we expect our branches to be in quadrants 1 and 2. Again, let's be smart about our numbers. I'm not going to use 1 here because that's going to be a 1 and a 16 for y. It's going to be way too big. So let's use, let's try negative 4, negative 2. Let's see what we get for that. So negative 4, if I square that, that's going to be positive 16. 16 divided by itself is just going to be 1. Negative 2 squared is positive 4. 16 divided by 4 is 4. So that's going to be in quadrant 2 because I have negative x's. Let's also do some positive values to be in quadrant 1. So if I do a positive 4, I'm going to get the same result. Positive 2, I'm going to get the same result. So now let's go ahead and make a picture of that. Keep in mind that we're not going to use the bottom half of the graph, so when you're making your picture, make sure you overemphasize quadrants 1 and 2. So when I graph here, I'm going to be at negative 4, 1, and negative 2, 4. And so that's going to be one of my branches. Go ahead and connect that one right now, rather than waiting, because it can look a little bit silly when you only have coordinates in both quadrants here. It's kind of hard to know how to connect them. So I would do one branch at a time. And so my other branch is going to look about like that. And it looks like what I anticipated that it would. It kind of looks like a volcano. Lastly, we need to discuss some vocabulary for these graphs. Since both graphs can't have a 0, that thing that it ends up going towards is called an asymptote. An asymptote, this is how you pronounce it, is what the graph approaches but never actually reaches. Keep in mind that asymptotes are not technically part of the graph, but you still might be asked to identify them. Asymptotes can be horizontal, vertical, or oblique. For the most part this year, the ones that students will encounter are the horizontal and the vertical ones. So let's look back at our graphs and try to figure out where those asymptotes may lie. Typically they are on the x and the y axes, but let's go ahead and verify that on the pictures themselves. So let's go back to our original hyperbola, and typically we draw the asymptotes as dotted lines. So notice how x can't be 0, and so the graph is really going away from that 0 point. It's going off to the right and off to the left, but it's never actually going to get there. So the x-axis ends up being an asymptote because x can't be 0. So the x-axis is never going to be reached. Same thing for the y-axis. If you notice, the graph is pointing up forever and pointing down forever. We're never actually going to get to the y-axis because we're never going to get a 0 for y either. So the asymptotes for this graph, both when it's positive and negative, are the x and the y axes. So let's add that to our notes. We're going to say asymptotes on the x-axis and the y-axis. So there's two asymptotes, a horizontal one and a vertical one. We don't have any oblique ones in this particular case. Let's take a peek at our inverse square curve. Do you see any asymptotes for these graphs? And again, same thing. The x-axis is never going to be reached, so that's an asymptote. Same thing for the y-axis. The y-axis is an asymptote here because we're never going to reach it in the upwards or the downwards direction. We don't really need the asymptote as it goes down into the negative region for this graph, but the whole y-axis does behave or act like an asymptote. So we're going to add that to our notes as well. The asymptote are the x-axis and the y-axis. So that's a commonality between the two graphs. They're both inverse graphs, and they both have asymptotes on the x and the y-axis. There's one more vocab word here. The book mentions whether or not graphs are discrete. Easiest way to remember this is just to say discrete has dots. If the graph has dots that are not connected, we refer to that graph as a discrete graph. Keep in mind that if that is the type of graph you're working with, the domain and the range will be either positive integers or whole numbers only.